So here we're just going to explain a little bit more about the Bruce system from Nextspace. This is a system to bring together data from lots of different environments, CAD systems, GIS systems, documents, images, video, point cloud data, IoT, Scada data, and so forth. And what we're seeking to do is apply the concepts of ontology to these different types of data inputs. The goal is to identify, as ontology requires you to do, to identify things of interest, their attributes of interest, the relationships between those things, and then potentially all the different visual ways to represent those things. So it's kind of an organizing and classification system. And what we're doing is able to bring in a whole range of different data. For example, the CAD data from plant and process. I'll use an example from the plant and process industry, but this conversation applies, as much for engineering, factory, manufacturing, architecture, construction, civil engineering. So any aspect of detailed CAD and engineering documentation and design. So we're able to bring in the CAD data and also all of the data attributes. For example, see here a valve, and all of the attribution is defined by the various CAD systems. And our goal is to identify this valve, but data that has come from a single CAD system, but to identify the same valve by its unique ID in different systems and actually map it to other data, such as point cloud information, all of the documentation that comes with it. This valve will have what's called a PID document. This valve will appear at some point on a schematic diagram, what's called an isometric diagram. There'll be parts lists, there'll be training videos to show how to disassemble and repair this this valve, and all of that needs to be brought together into a coherent fashion. It also needs to be located geographically, so we need to be able to bring together the GIS data along with all this other sort of information. And what we have to do is now classify that information in useful ways. So we use these mapping technologies, which will map one concept of a pipe or a valve or a thing from multiple different sources to be representing the same thing. So this tool sort of merges things together there. We can then host, this amalgamated data on a server. We use AWS today, but we could equally well be using Azure or DigitaloCean. We run with the Kubernetes system, which makes it cloud agnostic in that respect. And the result is that we can bring all of this together into a digital model, which is not just the CAD model plus the GIS, but a complete amalgamation of all of the information. So we see here, for example, the valve selected. In fact, this shows the actual tag and the specific valve. It's all this collection of data, the point cloud information aligned with the CAD data, all of the attribution as supplied from the source CAD system, panoramic images, and we see above all of the bookmarks and markups that might be applied. And we're looking at it here, in fact, in the cesium environment, which is a web-based environment, which is good enough for many cases. But now with the Omniverse, we're seeking to bring all this data together and to be able to serve it through the Omniverse environment. So what we've done is to now build USD assemblies, which are GUID and ontology enabled. So we're able to track the independent USD files right back to the source data of information. So we can now be driving engineering, procurement, general ERP data, different visual proxies, documentation links, and so forth, which will all be managed externally to the Omniverse, and of course even to Bruce back in source systems like SAP or a Scada system, or even the manufacturer's database. And so Bruce is gathering all this data together about all the things of interest, and then presenting them through in a highly visual fashion to the Omniverse environment. And what's really an important point here is that the data that goes to the Omniverse is not just the imagery information, but it's in fact all of the data. So we can leverage the Omniverse environment not just for visualization, but in fact for simulation, or augmented virtual reality, for artificial intelligence analysis, pattern finding, optimization of systems, and so forth. So by GUID enabling USD files, and also with attribution, we're able to actually create a far more complete picture, i.e. a digital twin of an environment which is far more suited to the whole range of possible applications of GPU technology from Nvidia. You'll see here that by connecting now this GUID-enabled USD file to Omniverse clients and using the Bruce connectors, we're able to not only visualize the data, but we can start linking all of the actual information. We see here a picture of the same plant that we saw before, represented the cesium environment, now represented in the Omniverse environment. And so this is inside of Create, but of course could be inside of View or the augmented reality environment. So we're working on various UI ideas, including flyouts for navigating, but this is actually working today. So we have the ability to represent the data in this form of pop-up panels, which will link to the data. We've tried it; it's working well in the virtual reality environment that's been tested, and we're able to make a complete picture of this world now, which is connecting the source data through this classification system, the ontology and GUID management, into this Omniverse environment. And not only that, but the same model can be simultaneously viewed, interrogated in the Cesium navigator and the Unreal Engine navigator. But of course, it's only the Omniverse that has the full power of all the simulation, AI, analytics, and so forth that our clients are finding very exciting as a concept, being part of that whole ecosystem. So I hope that's explained it well enough what we're actually doing with this. Again, the key is ontology and GUID management for the USD assemblies as part of the Omniverse.